This is an example of solving a linear inequality. We have negative 7x plus 4 is greater than 3 times the quantity 4 minus x. And the way you initially approach this is you just treat the inequality like an equal sign and essentially solve for x. I'm putting solve in air quotes here, but let's do it. Okay, so let's distribute the 3 through. We have negative 7x plus 4 is greater than 12 minus 3x. Okay, and now we have a choice. We can either get the x's on the left side or the right side, and I'll actually do it both ways. Let's start by getting it on the left side. So let's do that. Let's add 3x to both sides. And this matters. And I'll subtract the 4 from both sides because we have to approach this inequality a little different depending upon how we roll with this. Okay, so adding 3x gives us negative 4x greater than, and then subtracting a 4 gives us 8. Now here, we're still solving for x, so to speak, so we divide both sides by a negative 4. But anytime you divide or multiply across an inequality by a negative, you need to change the direction of the inequality. I'll write that. If you divide or multiply across an inequality by a negative, you must change the direction of the inequality. Okay, so it's no big deal. It's actually much easier to do it than it is to write all that out. Let's just do it. So this becomes x less than negative 2. There we go. Okay, and we don't represent our answers to inequalities like this usually. Usually we want to see the answer either by graphing or an interval notation. We'll do that shortly, but first let's look at this problem a different way and solve it by getting x on the right hand side. So we're taking the same problem, negative 7x, I'm just going to take it from right here, plus 4 greater than 12 minus 3x. Okay, now I'm going to add 7x to both sides. Okay, so that, and I'll subtract the 12 from both sides as well. So that gives us negative 8 is greater than 4x. And then dividing both sides by 4, that gives us negative 2 is greater than x, which is fine. This is the same answer. These two are saying the same thing. Oftentimes, it's a little bit easier to read these if you have the x on the left side of the inequality. So if you end up with something like this, I recommend, though you don't have to, but I recommend switching it around and just writing it in the order. So we can kind of write this from right to left, so to speak. So this would be x less than negative 2. And then it's exactly the same as we have down here. Okay, so why does it matter the direction that we write it? Well, because we need to actually represent our answers in two different forms. I guess depending upon the problem, what the problem's asking, it may want both, it may want one or the other. But here's what we call graph notation. And to do that, you start with your number line basically, and this is saying we're taking all of the numbers less than, but not including negative 2. So here's 0, here's negative 1, here's negative 2, and the way we want to represent this is by using a parentheses or a soft bracket here at negative 2. The parentheses shows us that we're not including -2. And then we go off in the left direction like this, because we're going down. It's all the stuff less than -2, so we're going down towards -infinity. Right. Another way to do this, depending upon your textbook or your preference, really either is fine, is you can do an open circle and then go down to infinity like that. Right. If this happened to be less than or equal to 2, we would do a hard bracket like that and down to infinity, or we would do a closed circle down to infinity. Okay, so those are the differences in notation here. But as you can already see, this graph notation is a little bit cumbersome. So what's a little more standard than graph notation is what we call interval notation. The interval notation represents what the graph notation says, but it does it in a more concise way. Okay, so what we have here, this is all this stuff down, so if we just kept going forever, we'd hit basically -infinity down here somewhere. We never get there, right? -infinity is not considered a real number, so we never get to -infinity, so I'm going to do a soft bracket because we're never hitting it, -infinity, and then I'm going up and I'm covering all the stuff up to -2. And then we didn't hit -2, so I'm going to do a soft bracket there. Right? If this happened to be less than or equal to, I would do -infinity up to -2, and then I would do a hard bracket. Okay? Because we actually include the 2 with the equal sign. Here we're getting infinitely close to 2, but we're never quite getting it. So we use this parentheses, our soft bracket, to represent, hey, we're getting infinitely close to -2, but we never actually touch it. And just that statement I said alone right there, you could spend a lot of time in mathematics just studying how to get infinitely close to something and what it means to get infinitely close to something without actually touching it. So we'll save that for, I guess, a higher level class. But that's what's coming, after a few classes down the line here. All right, so there's our interval notation, there's our graph notation. Let's try another one. Okay, for this one we have 7 times the quantity x minus 2 plus x is greater than or equal to -4 times the quantity 5 minus x minus 12. So let's talk about this. Let's treat this again as solving for x. So I'm going to treat this inequality like it was an equal sign, and then just be a little bit careful because it is an inequality. But let's just move forward. I'm going to distribute this 7. I'm going to distribute the -4. Let's see what that gives us. 7x minus 14 plus x is greater than or equal to -20 plus 4x. Right, because a negative times a negative made it positive, which is why this became positive 4x. All right, then we still have this -12 hanging out over here. All right, let's combine like terms here. So let's see, those x's can go together. The -20 and -12 can go together. All right, so we have 8x minus 14 over here, greater than or equal to, looks like -32 plus 4x. And now, like we saw in the last example, it's a little easier if you can keep the variables positive. So I'm going to subtract a 4x from both sides here. Right, to keep that positive, because that gives us 4x now minus 14 on the left, greater than or equal to -32. And now we can just add 14 to both sides, which gives us 4x greater than or equal to -32 plus 14, I'm thinking is -18. All right, now we're getting close. Divide both sides by 4. This gives us x greater than or equal to -9/2. Right, we can get a 2 out of both 18 and 4. Okay, but that's not our answer, at least not usually. Usually you want to write this in either graphical notation or interval notation. So let's do that. Here's the graph notation. All right, so this is everything greater than or equal to negative 9/2. So it's all the stuff bigger than that. Okay, well, it may help to use a calculator to figure out where 9/2 is on the number line. Right? It turns out negative 9/2 is the same thing as negative 4.5. Okay, so here's 0, 1, 2, 3, 4. So here's negative 4. Here's negative 5. So 9/2 is right here between negative 4 and negative 5. Okay, and it's greater than or equal to, x greater than or equal to. So that means we're going to include the point in our graph notation here. And we do that by using these hard brackets. You could also do it by using a closed-in circle. And then it's all the stuff bigger than negative 9/2. So I'm going to just fill in the number line off in the right direction all the way out to infinity. Okay, or you could do it with a solid circle and go out to infinity, also on the number line. And this point right here, it's not entirely clear. This is negative 9/2, or negative 4.5. Okay, so that's the graph notation. And then interval notation. So the interval notation okay, we want to represent this graph. What this graph does is it starts at negative 9/2 and it includes the point negative 9/2. So I'm going to use my hard brackets, and then it includes all the stuff off to infinity. So it starts there and then keeps going up to positive infinity. And infinity never gets a hard bracket because infinity is technically not in the real numbers, and we're working only in the real numbers. So there's the interval notation. Anytime you're using interval notation, if you have an infinity, it always goes here on the right side. Right? This isn't an ordered pair like a point. This is representing an interval. And if you have a negative infinity, it goes on the left side, right, leaving space for something else. Okay, so always on the left for negative infinity, always on the right for positive